Hello everyone. Today in this video we will discuss about product of inertia topic. It is denoted by Ixy. Now coming to the parallel axis theorem for the product of inertia, it will be similar to the parallel axis theorem which we have studied for the area moment of inertia with slight differences. Now we will see the differences when we compare the parallel axis theorem for the product of inertia and parallel axis theorem for the area moment of the inertia. And the parallel axis theorem for the product of inertia is expressed as Ixy is equal to Ig x dash y dash plus A hx hy. Now here in the parallel axis theorem for the product of inertia we have three terms. First term is Ixy. Ixy is nothing but product of inertia about x and y, and Ig x dash y dash is nothing but product of inertia about its centroidal axis, and A is nothing but area of the complete plane figure. And coming to the hx and hy distances, this is the first difference when you compare the parallel axis theorem for product of inertia and area moment of the inertia. Now everyone observe this diagram here. If we consider any plane figure, here you will have the centroid point, and here this complete plane figure is in the xy plane. So here hx is the distance between centroid of the plane figure and y axis, and hy is the distance between centroid of the plane figure and y axis. So in the parallel axis theorem for the product of the inertia, you will get the hx and hy distances directly from the centroid point to their axis, x axis and y axis. So this is the first difference. And the second difference is here you are getting Ig x dash y dash term. So this term will be mostly zero value in the problems. Why it will be zero means product of inertia of any area will be zero if one or both reference axis or axis of symmetry of area. For example, if you consider any rectangle area, then here G point is there, that is the centroid point of this rectangular area, and here x axis is the centroidal x axis, and here y is nothing but a centroidal y axis, and this complete rectangular area is symmetrical about x axis as well as y axis. Suppose for example, if any plane figure is symmetrical about x axis or y axis or both reference axis, then for that particular plane figure, here rectangular figure, then for that plane figures product of inertia about its centroid point, it will be zero value only. So here most of the problems you will get a combination of triangular sections or rectangular sections or I sections, L sections, channel sections. So those are coming from the rectangular plane figure diagrams only. So for such type of the plane figures, mostly in the problems you will get this term as zero value. Now this is the second difference. So with these differences you can apply the parallel axis theorem for the problems, and you can calculate the product of the inertia for the composite sections. Suppose for the composite sections are given in the question, then you need to use the plus sign in the last calculation. Suppose if you are getting a cutout sections, then in the last calculation part you have to use the minus sign. Why? Because cutout sections are there. So you need to subtract the cutout sections from the main sections. That will be the difference, but remaining procedures will be same only. Now we will see one problem. Here they are asking to calculate Ixy for the angle section. So this is the given diagram with the dimensions which are in the centimeters, and units for the product of inertia are centimeter to the power of 4 or meter to the power of 4 or mm to the power of 4 according to the dimensions which are given in the question. Now we will see the procedure for this L section. Now actually this is the main diagram. So we need to draw the main diagram, given diagram once again in this manner, and locate all h distances to the x bases and y bases, and location of the centroids also. Now here let us consider this section as the first section and this section as the second section in this way, and locate the centroid points for the first and second sections. Next, write the individual dimensions for the first section as 3 centimeters and 1 centimeter, and for the second section 4 centimeters and 1 centimeters, which are given in the question directly. Next, here they are asking to calculate product of inertia about xy. So we need the x base and we need the y base to get the h distances about y axis and x axis also. So project x base and project y base. Now we know that from the individual sections centroid points to their base x base and y base, you will get the direct h distances in terms of the x and y. So here for the first section, from the centroid point of the first section to the x base, hy1 distance. Next, from the centroid of the second section to the x base, hy2 distance. Next, from the centroid of the first section to the y base, hx1 distance. From the centroid of the second section to the y base, hx2 distance. So from this diagram we got the hx1, hx2, hy1, hy2 distances. So by using these distances we can calculate the ixy for the first section and ixy for the second section. Now we will see the procedure. As this is a L section and L section is a combination of two rectangular sections only. So what are the formulas for the rectangular section? Area formula is BD and x bar formula is B by 2 and y bar formula is D by 2. So based on these formulas we can calculate all the h distances. Now we will calculate the ixy1, that is nothing but product of inertia about xy for the first section. Area value. For the first section, B value is 3 and D value is 1. So 3 into 1. Next, as it is symmetrical about x axis and y axis, both axes. So you will get Ig value for the first section, 0 value. Next, hx1. Now see here, from this point to y base, hx1. So 3 centimeters is the dimension up to the first section only. So formula will be applicable up to here only. So 3 by 2 according to the formula, plus 1 up to the y base. So 3 by 2 plus 1. Next, hy1. hy1 is nothing but here. Complete depth value is 1 centimeter. So half of the distance according to the formula. So 1 by 2. Next, substitute all these formulas in the parallel axis theorem. You will get the ixy1. That is nothing but product of inertia for the first section. Next, for the second section, ix2. Area value. Area value is nothing but 4 into 1. So 4 into 1. Next, Ig value will be 0 as it is a rectangular section. Next, hx2. hx2 is nothing but here. For the second section, base value is 1 centimeter. So 1 by 2. Next, hy2. hy2 is nothing but from this point to this point. So depth value for the second section is 4 centimeters. So 4 by 2. Apply all these values in the parallel axis theorem. You will get the ixy2. That is nothing but product of inertia about xy for the second section. Now as it is a composite section, add ixy1 and ixy2. You will get the ixy for the complete L section. So ixy, product of inertia about xy for the complete L section, you will get in terms of centimeter to the power of 4 value. So this is our problem. Once again see the given diagram and see the problem. So this is our problem for product of inertia. Now we will see mass moment of inertia. Now mass moment of inertia is nothing but we will get, actually moment of inertia is of two types, like area moment of inertia and mass moment of inertia. You will get the area moment of inertia for the plane figures in terms of like area into perpendicular distance square, and for the solid bodies you will get the mass moment of inertia. That is nothing but area moment of inertia is replaced by mass moment of inertia for the solid bodies. So in place of the area you will get the quantities like mass, and perpendicular distances will be same only. To the x base you will get the y distances, and to the y base you will get the x distances, perpendicular distances. So here area is replaced by mass for the solid bodies. So for mass moment of inertia is given by mass into perpendicular distance square, and the units are expressed in kg meter square. Why? Because here mass value is there. So mass units are kgs, and perpendicular distance square, distance units are meter square. Suppose in the problems if it is given in terms of the centimeters, so you will get in terms of kg centimeter square. According to the dimensions which are given in the question, you will get the units for the mass moment of inertia. Now we will calculate one problem for the mass moment of inertia. So this is the given diagram and given problem. Calculate mass moment of inertia of the composite body about vertical geometrical axis. Vertical geometrical axis is nothing but, for this diagram, vertical axis is nothing but y-axis. So y-axis about geometrical axis. So we need to consider the geometrical considerations of the first section and second section also. And here density values are given for this question. So here actually in this complete composite body, two sections are there. So first section is brass cone and second section is aluminum cylinder. So for the brass cone, density value is given as 85 kilonewton per meter cube, and density for aluminum cylinder is given as 25.6 kilonewton per meter cube. So density values are given for this composite body, and we need to calculate Iy value. Iy is nothing but mass moment of inertia about vertical geometrical axis. So we need to calculate Iy value. Now we will, as here two sections are there, so we need to calculate Iy1 and Iy2, and we need to add them to get the total Iy value. So first of all we will calculate Iy1, that is nothing but brass cone first section. So as we know that volume formula for the cone is pi r square h by 3, and here I want to tell one thing. Generally formulas are based on the default diagrams only. The default diagrams are coming from the geometrical considerations like position of that particular diagram and shape of that particular diagram only. So based on that geometrical considerations and default diagrams only, formulas are derived from them. So there will be fixed formulas, default formulas for the default geometrical consideration diagrams. So we need to consider those default formulas and default diagrams in the problems also. So once suppose for example if any geometrical consideration like position or any axis is changed in the problem, then formula will be changed according to the position of that particular diagram. So we need to remember this thing. So here actually this is the default shape diagram for the cone, and for this default shape, this is the formula 3m r square by 10 is the formula for Ix. Ix is nothing but here along this x-axis for this default cone diagram, this is the formula for Ix. Now observe our main problem which is given in the question. This is the cone which is in the vertical direction. So position of the diagram in our problem is changed. So formula will be changed according to the position of the diagram. So here Ix is nothing but here Iy only in our problem. So Ix formula for the default diagram is nothing but Iy formula for our given problem. So here Ix formula is nothing but Iy formula for the brass cone first section. So here Iy1 is equal to 3m r square by 10. Next, we know that mass formula is density into volume, and we also know that 1 kg is equal to 9.81 Newton. Why we are using this value means here in the problem density values are given in terms of the kilonewton per meter cube, but we want the density values in kg per meter cube. So we need to convert this kilonewton per meter cube into kg per meter cube. Like as here density value for the cone, density value for the brass cone is given as 85 kilonewton per meter cube. So first of all conversion into Newton. Kilonewton into Newton means 10 to the power of 3. So 85 into 1000 Newton by again Newton conversion into kgs. That is nothing but here 1 kg is equal to 9.81. So divide by 9.81. So you will get in terms of the kg per meter cube. Next, we know that mass formula is equal to density into volume. So we got already density value. Next volume formula we know for the cone as pi r square h by 3. And one more thing, here every value is given in terms of the mm. So convert all the dimensions which are given in the question into meters. Like here everyone see for the cone diameter is given as 400 mm. So radius value will be 200 mm. So 200 by 1000 conversion into meters, 0.2 meter. Next height value for the cone is given as 225 mm. So 225 by 1000, 0.225 meter. So convert everything which are given in terms of the mm into meters. Next substitute all the values r value and h value in the volume formula. We will get the volume value. Next substitute that volume for volume value in the mass formula. So you will get the mass value in terms of kgs. Now what is the formula for IY1? That is nothing but 3m r square by 10. M value we have calculated. R value that is already given in the question. We have converted into 0.2 meter. So substitute all the values. We will get the IY1. Mass moment of inertia for the brass cone. That you will get in terms of the kg meter square. So for the first section calculation is completed. Now for the second section. Second section is nothing but aluminium cylinder. Now for the aluminium cylinder. Now this is the default fixed diagram. Here it is the x-axis, here y-axis, here z-axis. So in the default position diagram, default formula about z-axis. Z-axis is mr square by 2. Now observe this default diagram with our problem diagram which is given in the question. So here z-axis in the default diagram is nothing but y-axis in our diagram, in our problem diagram. That is nothing but iz formula is nothing but iy formula for our aluminium cylinder which is given in the question. So iy formula for our problem will be mr square by 2. Next we do the same procedure for the second section also. Like we know that mass is equal to density into volume, and density is given in terms of the kilonewton per meter cube, that is 25.6 which is given in the question. So convert the 25.6 into kg per meter cube into 1000 by 9.81. You will get in terms of the kg per meter cube. Next volume formula for the cylinder is pi r square h by 3. Again values are given in terms of the mm only. Like here for the cylinder diameter is given in terms of the 400 mm and height value is given in terms of 300 mm. So convert that 400 and 300 into meters for radius value and for the height value. Substitute all the values in the volume formula. You will get the volume value. Next substitute that volume in the mass formula. You will get the mass value in kgs. Next substitute all those mass values and radius values which we have already calculated in the IY2 formula. That is nothing but mr square by 2. Mr square by 2. You will get the value in terms of kg meter square. And now we have calculated IY1 for brass cone for the first section and IY2 aluminium cylinder second section. Now as it is a composite body, we need to add both the values. So IY1 plus IY2, that is nothing but total mass moment of inertia about vertical geometrical axis for the composite body, that you will get in terms of the kg meter square. So this is the problem for mass moment of inertia. Once again see the main diagram and IY1 calculation and IY2 calculation. So these are the problems which are related to mass moment of inertia and product of inertia.